Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects, titled A Novel Cluster Head Selection Approach with GWO Optimization. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Hello friends, welcome to TechPacks Research and Innovation Services. Today I'm here to present you one of the applications that we have designed for the clustering protocols in the wireless IoT systems. Where the sensors that are collected and transferred to the remote location by using this protocol and preserve the energy. So let's move to the video. Before moving to the video, let's talk about what we will cover into it. We will initially talk about the application areas in which it can be implemented and is useful. Then we will talk about how to execute the code, which files we will provide, and what are the software and library requirements for it. Next to that, we will talk about what are the current systems, those are working in the same domain, and what are the problems identified with them. Finally, what exactly we have done in the proposed system will be given. An overview to the experimental outcomes and findings will also be given in the end. So let's talk about the application areas. As I already told that we have designed it for the wireless IoT, WSN IoT system. So it is implemented in many of the application. It can be implemented like smart agriculture or smart buildings, so intelligent transportation, smart medical healthcare systems, current cars transportation systems, smart industries, internet of things, wireless technology, medical treatment, and many other domains where the sensors can be deployed at the remote location and can be sensed at that remote location by using the internet of things, and our objective is to preserve their energy. So let's move to the code. For the code, we will give you the folder name like this, under which library code is there in the code file. The whole code is implemented in the MATLAB, so you must have the MATLAB software installed on your system. So here the MATLAB that I'm using is MATLAB 2019A. You can use 2015 or the higher version. So in order to run the code, just go to the folder where the whole code is placed and just copy the path, and then go to the MATLAB and paste it here and press enter. You can see all the files can be seen here. Out of this, you can see this is the main file that you need to execute. Other than that, this is the comparison code with us, and this is the results that we have taken from the base paper directly. So you need not to run it separately, so just hold it down. So the main file you need to run is proposed code, and for the comparison you need to run this one. In the proposed code, when you will click on the run button, it will start executing the code and will show you the result at the end. In the meantime the code is running, let's talk about the work. So we were considering this base paper in which they have used the hybrid meta-heuristic optimization algorithm for the energy efficiency in the wireless network. They have used a hybrid model of ant colony optimization and PSO, and did the clustering part with the energy factor only. So the problem that we have identified first is, like, they are only considering the energy factor, but only energy is not the effective for selecting the cluster head in the network. Other than that, the certain parameters affect a lot. Other than this problem, one of the problem that we identified, that ACU and PSO are very old fashioned and old programs, and having the issues when they get stuck in the local optima, and ACU is specifically when you need to form the chain only. So this system will increase the complexity, and the degraded results will be there. So in order to avoid this issue, so one of the proposal that we have given is, other than the energy, add the communication distance factor. Secondly, to replace the ACU and the PSO, use the GWO, that is gray wolf optimization, GWO optimization algorithm. So it is a gray wolf optimization proposed in 2014. So use it. So let's see what we have done in the code. Initially, the network has been initialized, initial energy is given, energy model data is given, sync location and initial points have been generated. So for individual rounds, what we are doing, every time the status of the node is being calculated, and we are checking that which node can be the cluster head, and then we are calculating these are the tentative cluster heads, and for that we are that gives us the information that can be used further for selecting the data set. So here you can see we have saved the distance as well as we have saved the node number to which it is nearer. If the cluster head is calculating its distance with itself, obviously that will be the zero null, so we need to remove that information. So now while selecting the cluster head, the GW optimization is being implemented, which is evaluating the cost function. So the cost function, under the cost function, we have mentioned the parameter energy and distance. Two of the parameters we have used, those are giving us the best cluster head within the cluster. So as the code is running, that's why it is not opening. Let me open it later on. In the meantime, let's close the code. So GW will give us the best cluster head nodes, and then we are performing the communication where the distance among the cluster head selected and the cluster member will be calculated, and as per the concept of the energy model, if the distance is greater than d naught, the energy equation will be this, else the another equation is to be used. This is the conception of the cluster members communication. Then the communication between the cluster and the sink is being done, and finally the factors like throughput, packet delivery ratio, all those factors has been calculated. The final comparison has been shown in the multiple parameters like dead nodes, alive nodes, packet send, energy consumption, half dead nodes, first dead node, last dead node, all these factors. Because the base paper is calculating the similar results, then only we can do the compare if we will calculate the same factors like the packet count, alive node, dead node, energy consumption, and first node dead, last node dead information, right? So on that behalf, you can see it is still running, as the uh, count of the rounds we have given here is 7,000 rounds. So far 37,000 rounds has been run. So let's wait rest of the rounds to get finished. So GW is playing an important role in selecting the node which can be the clustered within the cluster with the best energy and the least distance among the communication nodes, so that that can be the best outcome. So you can see we just reached to 4,000. It will take some time to give you the results. So for doing the comparison, once it was done, we have saved those results to simulation.mat, which we will use in the comparison one. But firstly, let the simulation get closed. So here you can see the graphs that we have achieved. This is the number of dead nodes, this is the number of alive nodes, this is the packet sent to the base station, this is the energy consumption of the proposed system. So if we need to do the comparison, we just need to run this comparison code. Before running the comparison, let's talk about the cost function. So here you can see when the GW was evaluating the best node for the cluster head, here it was going to the cost function. The cost function is basically whatever the node is elected as a cluster head comes under the GW. It calculates the distance from the rest of the nodes in the cluster and then the residual energy. The equation of the fitness is energy divided by the distance. So under that factor, whatever the node is getting the better result is selected as the cluster, and the results are with us. So in the comparison one, whatever the results we got, we saved them as a simulation.mat file, and the traditional results we have taken from the base paper directly. These files have been taken from the base paper, and when I'm running this, you can see the different graphs with you. So the results that we were talking about, this and this we have earlier seen. This is the first node, half node, and last node dead round. This is the comparison with the traditional ACO, PSO, and the proposed GWO. So you can see the packet count is higher, that are reaching to the base station in comparison to the traditional one. And next, live nodes. You can see the ACO PSO is getting depleted early, whereas proposed is stable for a longer period. Similarly, for the energy consumption, it is also better in our proposed method. So further modifications are still possible into it. For that details, you can contact us directly. Thank you. Thanks for watching the video.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPacks, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPacks. We look forward to collaborating with you on your research journey.